Okay, so chapter 6, systems of linear I bought this cheap lead off of Amazon. Worst decision ever. Breaks like crazy, and I was told it wouldn't. Okay. Chapter 6, systems of linear inequalities. So review from IPR. That's, by the way, Intro to Applied and Pre-Cal. That's what the code is for that. I want you to remember there are 4 types of slopes. Do you remember what slopes? Slopes are essentially going to tell you the steepness and whether or not it's going down or up, it's increasing or decreasing. So for that, I've developed this very helpful column-Mr. slope. Okay, so if a line ever goes up from left to right, you always read a line from left to right, just like you read a book, right? It'll be positive. If the line is going down, you'll have a negative slope. If the line is going vertically, you have an undefined slope. And if the line goes horizontal, it's a 0 slope. I don't know. I picked this up at some point. It's not. I can't trademark that. But anyways, that should help. I saw it somewhere, and I was like, you know what? This is awesome, right? And so those are the 4 types of slopes: positive, negative, undefined, 0. Okay. A horizontal line has 0 slope, right? No rise. So it's always going to be 0. A vertical line has no run, okay? So I'm going to review that with you here. Slope, the letter M is used for slope, okay? And that would be rise divided by the run. So for a horizontal line, you'd have to agree with me here. What's the rise? No matter which 2 points you pick on it, you're going to end up with 0 over some kind of number. You're going to run, right? If you pick 2 numbers, you might run 5 units, 10 units, it doesn't matter. But 0 divided by anything is always what? I don't know. Let's see, right? So you go 0 divided by 1,258. It's still 0, right? There's nothing you can do about that. That's why it's a 0 slope, right? Horizontal lines, right, have a slope of 0. And then there's your vertical, right? Where the slope is going to be, there's going to be some kind of rise, right? Depending, remember you always need 2 numbers, you need 2 points on it to calculate it. Do you remember y2 minus y1 over x2 minus x1? Does that ring a bell? It does. I know it does. You were always paying attention, right? When you logged in online, you're totally there the whole time. This is a number over, the focus is 0, right? Because you're not running. You're not running. Okay. So no run, right? Therefore, that's there. Let me go up here, no rise. That's why you get that 0 on the top. And so anything divided by 0 is what? It's not 0. 9,587 divided by 0. Error, divide by 0. Some calculators will say just error, undefined. It's undefined, you cannot do that. Right? So you don't go equals, you just say undefined. Okay? Don't say the slope is 0 for a vertical line, it's actually undefined. So vertical lines have an undefined slope. Okay? And then positive or negative, right? It's just going to be what it is. So, for example, if you had a line that goes up, without even calculating it, you know it's going to be positive. But let's say you start at -2, 3, and you go along, and you always have to be strategic with picking your points, right? You don't just pick a random point. You actually pick where the grids cross, right? A perfect crossing. So let's say this is 5, 4. And I'm not giving you a whole grid because we're going to do that later. But to find a slope, you go y2 minus y1 over x2 minus x1. And you're like, what? Right? So you choose which one you want to make your x1 and x2. You choose. I will choose to make this x1, y1. This is x2, y2, right? To make a distinction between those two coordinates. And so let's go ahead and plug that in. y2 is 4. The minus, actually, let's do this because this is the most common mistake, IPR included. Put the negatives in right away. That's part of the formula. And then it may be the case that a number is actually negative as well, right? So I go y2 minus y1, which is 3, right? And then I go x2, which is 5, minus, what's x1? It's -2, right? And so 4 minus 3 is 1. 3 minus -2, it's actually what? Positive, right? 5 plus 2 is 7. So this is your slope, and it's positive. It's a positive overall. You're rising 1 and you're running 7. And this is going to be the case throughout the function, guys. It's going to be 1, 7, 1, 7, right? So 1, 7, 1, it's like a staircase. 1, 7, 1, 7, 1, 7. But we only connect these points here to make our line. Okay. 1, 7, 1, 7. Throughout the thing, it's always 1, 7, 1, 7. It doesn't matter which 2 points you pick on that line. Once you reduce that, you should always get 1 over 7. That's why it's linear, right? A parabola doesn't have a constant slope, right? Because it curves and goes like this, right? So that would be a difference there. Then you have your decreasing lines. Left to right, it goes like this. And so let's say you start at -7, 6, let's say. And then you end up at 8, -3. And I'm totally making these up. I kind of have my script, but some of the things I just make up, okay? Calculate the slope, please. You do it. Let's see if you remember. And it's so critical to get the sign right. You're waiting for me, right? That's how it goes, right? So my slope here, without the formula, you may have done x1, y1, x2, y2, right? So you go and put the negatives, the minuses right there. You're going to take the difference, right? So this is -3, right? -6, and then it's 8 minus -7. Okay. And here we go. When you have negatives like this, you add them, right? You add negatives essentially. So this would be -9 over when two negatives are right beside each other, that's a positive, right? So this would be 8 and 7 is 15. So overall, I always tell my students the negative floats up, right? Like let's say this had been negative, I always make it float up so that it's negative there, but in this case it just happens to be. You can reduce this further, right? You can divide both of them by 3. So this would be negative 3 over 5. Right? That's your slope, and you know it's negative. So that means that we're dropping 3, running 5. Dropping 3, running 5. Right? You drop 3, you run 5. Drop 3, run 5. And so we're connecting these dots here to make our line. Sorry, missed that one dot there. Let's make it bigger. There. Anyway, so this is your just reviewing slopes. You should know where it's going from there. Okay. To be honest, it is gonna show up from time to time, but it will be fairly simple to calculate most of the time. So as long as you know as long as you remember your formula and that it's rise and run, you'll be fine. And it must be a negative slope if it's dropping. It must be positive if it's going up. All right, let's keep going. The back side here. Let's do some graphing and stuff like that. Graphing linear equations. By hand, I must add. I will actually make you do a lot of it by hand because there's a bit of an issue if we don't. So let's say you get 3x plus 2y is minus 6 is equal to 0. Let's do one of those. There was general form, standard form, slope intercept, right? You don't need to worry about remembering that, to be honest, but there's different forms of the linear. And so to graph it is, I will give you the steps, okay? Method 1, find intercepts, then graph. Let's do that first. This is the one that I'm going to prefer, and you'll see way down the road why, okay? What I do here is as follows, guys. I make sure the x and the y are on the left side of the equal sign, and the 6, what happens to the 6 when you bring it over to this side? It goes positive 6, right? Like that. You could have added 6 to both sides, you get the same answer. And then I go like this. I find the x-intercept, which means what? Y is equal to 0 at that point. And I make a bit of a t-chart. The y-intercept, if you're finding the y-intercept, x is equal to 0 at that point. And I just make a t-chart like that. And I use this equation for both instances, right? So if y is equal to 0, it turns out to be 3x plus 2 times 0 is equal to 6, which really is 3x, because 2 times 0 is just 0, right? Is equal to 6. And in this case, I would just divide both sides by 3. And x is equal to 6 divided by 3 is 2. So you found, what you just found is that, right, when y is equal to 0, x is equal to 2, which we call the x-intercept. On the other side, if you want to find the y-intercept, x is equal to 0. And the reason why we like these ones is because zeros are actually our friends, right? When it comes to substituting, it makes life a lot easier. So we're going to go 3 times 0 plus 2y is equal to 6. which means that really you're only left with 2y and equal to 6. And I picked these numbers. They're going to be nice and round numbers for this example, but it won't always be the case. We divide both sides by 2 because we want to isolate y, right? Y is equal to 3, right? That's 0, 3. And you found your y-intercept. And then I boxed that in. And down the road, you'll see why I'm doing this. I connect everything. I try to make it consistent so that you can use this skill later on for other things. So then you grab your ruler, if you have one, if not, anything that can make straight lines. And look at these points to guide you in your decision making for scales. These are fairly small numbers. So I'm just gonna do this right next to this. Okay, so you just label this X, this Y, and we're going to word problems, remember that. So I'm gonna go 1, 2, 3, 1, 2, 3. As long as you're consistent, I'm going 3 in every direction. And so 2 zeros right here. 0, 3 is right there. Without graphing it, what kind of slope would this be out of the 4? You look at Mr. Slope. Positive, negative, undefined, or 0? It's going to be negative from left to right. It's going down from left to right. Always read it from left to right. I tell students, just like you read a book, just like read anything, left to right. What's happening to the line, left to right, and then you know. And we always add our equation to it. Boom, that's it. This is a simple example. I'm going to tell you that the numbers are going to get bigger. So it's going to be 20s, 30s, 200, 400, whatever. It doesn't matter. We just, if the scale is 1, you don't have to put numbers down. Okay? If the scale is going to be anything other than 1, you need to put numbers down on your axes, right? Maybe every other one, right? And so that's how you graph it. This is the second method. But I just want you to know about it. I don't want you to really use it all that often, but we're going to need to know how to do it. Method 2 is rewrite equation. Rewrite or rearrange equation into y is equal to mx plus b. Do you remember that one? That one is the most popular. That's the slope intercept. Slope intercept. Does that ring a bell? That was the most popular one. Yeah. So y equals mx plus b. We know that m is the slope. And what is b again? It actually gives you the y-intercept. B actually gives you the coordinates of the y-intercept. So it would be like this, 0, b. Not working? Okay. So 0b. So let's do that. So if you have 3x plus 2y minus 6 equal to 0, I go way to the original. You bring everything that isn't. So these are terms, right? 3x and negative 6 are terms. I can bring them over to the other side. So this would be 2y is equal to negative 3x plus 6. You need to understand that I'm switching the sign, okay? And this is where a lot of students make a mistake, right here. Because it's 2y, you would have to say I'm dividing both sides by 2, correct? Both sides by 2. And so this will end up being y is equal to negative 3 over 2 x plus 6. And I hope you you see the mistake. I made a mistake. The 2 affects the 3, but it also affects the 6, right? So this is what? 6 divided by 2? It's 3, okay? And you already knew that because this is our y-intercept, and we already calculated up here that the y-intercept is 0, 3, right? So this jives. It should jive. It should all be connected. So my slope is negative 3 over 2, and the y-intercept is 0, 3, which comes straight from here. Okay? And so basically you use your slope, right? You start here and then you use your slope to find more points on that graph. And I'm not going to use the one above. I'm just going to do this one. Just do another one. It shouldn't take you that long. Right there. X, Y. 0, 3 is your starting point. You start with it. Okay? 0, 3. And I cut it short here. Rearrange equation into this. And I need to add a line. I don't know if you have space. I hope you do. Then use y-intercept and slope to find points. Okay, here's what I'm going to do. If you don't have room, watch. I'm going to add here something right next to the graph. Ready? Start with y-intercept, then use slope to find more points. How many points do you need to graph a linear? 2. Your teachers may have said 3 in IAPR. You only need 2. For quadratics, you need 3 to do a regression, right? So, and it has to do with the degree of the function. But watch what I'm going to do here. Perhaps I'm going to use a different color to do the slope thing. So this is telling me what? I'm dropping 3 for every 2 units that I'm running. So I'm going to go 1, 2, 3. And I need a scale here, right? It needs to be there. And I'm going to run 2 units. So 1, 2. So you basically found your second point, which happens to be the x-intercept, right? So you're dropping 3 and you're running 2. And there's your graph. I'm going to prefer the first method, to be honest. And one more go at it using our calculator. If you want to grab your calculator at this point. We cannot enter this one into our calculator. We can only enter something that's isolated like this one here. So let's type this one into our calculator because you will have to do that at some point. Clear? So I'm going to watch how I enter it. If there's a fraction, no big deal. I use brackets. I'm going to go negative 3 divided by 2, close brackets, x plus 3. And I'm going to use Zoom standard because I know I'm staying within the first. Zoom standard will do the trick just fine for us. Do you remember how to find the y-intercept? Second trace 1. Second trace value, right? Value. And if x is equal to 0, y is equal to, surprise, surprise, 3. And how do you find the x-intercept? Do you remember that? y2 is equal to 0. Hit graph. Then you go second trace 5 and just hit enter, enter, enter. And there it is, it's 2, 0, which we already knew was the case, right? So you can use your calculator to check if you want, right? To see if you rearrange this properly, right? And so calculator is still going to be a very useful tool, but I'm going to focus on this, right? On this one right here. However, this is going to be very important for you to know how to get your slope and how to get your y-intercept off of a graph. Okay, let's keep going. I'm going to give you some to try here. I'm going to talk about special cases, the special forces. Special cases. Okay. I'll tell you this. If you see x is equal to, I'm just going to go number, okay, number sign. Okay, then you have a vertical line. If you see y is equal to a number, what kind of line will that be? It's going to be a horizontal line. Sometimes it won't be visible, you won't get it right away. You'll have to do some isolating. We don't like that word, right? After COVID, gives you bad memories, right? Isolating. But so let's say, for example, you have something like this. At first glance, it may look like it's just a regular equation. First glance. But when you bring stuff over, okay, so you have 2x. I'm going to bring the 3x over to this side. It's going to be negative 3x. The negative y is already on the left side. This y is coming over, adding, right? One second, guys. Can you add a 1 here? It's better. It's going to be better. Just add a 1 up here to that original. I'm going to leave the 1 on the other side because that's normally what I do. I bring the x's and the y's over to the left. I leave that one number, the constant we call it, leave that on the right side. And then so 2x minus 3x is negative x. Negative x and, sorry, negative y and y just cancels out, right? You're left with 1. You can't have negative x, right? So you need to divide both sides by negative 1. And so x is equal to, what's 1 divided by negative 1? You guessed it, negative 1. So this is now a special case, right? This is not a point. That's why I like to write points as a coordinate. This is an equation. So it's a vertical line. Okay. So where would this go? Let's just sketch it. I don't want to use a ruler for this one. It's basically saying x is always going to be negative 1. No matter what, it's always going to be negative 1. So you go to the negative 1 here. This is the negative 1 mark. And that's where your line would be. I'm going to use a different color for that. But that is the line you're drawing. Okay, this is the line x is equal to negative 1. Remember the axis of symmetry? That was x equals something, right? Yeah, it's always vertical. And here's a cool trick. I didn't know this until last year. Students kept on asking, how do you graph a vertical line? What did I do? Oh, how do you draw a vertical? And I YouTubed it, and sure enough, there was somebody that figured it out. Okay, so ready for this? I'm going to add that to your notes here. To graph a vertical line on TI-84, we go like this. You have to put in 9 nines. I know, it sounds crazy. But seriously, what if I put 10 in there? 10 nines. It's okay, it's still going to work. But you need 9 nines. And then you need to go x minus the number you're interested in. And that's going to graph. Yeah. Yes, you can do that. I will not use that, but if you feel comfortable with it, go for it. Yeah, I don't use it because sometimes it actually gets a bit confusing. But if you want to use it, go for it. Yeah. Is there a vertical line though to be graphed there? Or are you just talking about inequalities? Okay, I will explore that. So I always get schooled, like you young people with your technology. You always school us, old folks. I love that actually. But for now, I'm going to stick with my method, okay, Jalen? If you don't mind. So I'm going to go 999, 999, 999. And I'm trying to graph -1, correct? So this negative stays. The minus has to stay there. You're going to end up putting in -1. So what is that really? Those two negatives really end up being a positive, correct? So let's enter that. 1, 2, 3, 1, 2, 3, 1, 2, 3. There you go. X plus 1. And then, so it's the opposite of what you are given, right? If it's -1, you're going to have to type in +1. So let's hit graph. Let's see if that works. There it is. That's your line, x equals to -1, which is this one, right? So if you want to graph it, Jalen, can you do this? Can you walk me through it again? Yeah, you can tell us what to press to also make that work.
With apps.
Yeah.
And then 7.
Inequalities.
Yeah, and then you just go up to the x, enter, and then you have your x values.
That's pretty cool. So you can actually just type in -1, I'm guessing. Oh, graph 2 lines there. So, oh, got it. Okay, for this to work, you need to go to apps and you need to go to inequalities something, right? You need to turn that on. And so for me, I have it on already, so I can just go continue. But if you don't want it, you quit, or else it will kind of mess things up. So again, apps, inequalities, you just hit enter. And if you want X, you just type that. The only problem is, okay, hold on. Let me try something real quick here. So this is -1. Okay, I got to go back to my Y, and I can type in 2x minus 3, I'm guessing, if I wanted to, and it would graph them. Okay, it graphs them both at the same time. It's up to you what you want to do, guys. You're the tech savvy people. So what I'm going to do for now is I'm going to turn it back off. I'm going to quit inequality. And so I would have to do the 999 thing. Jalen, did you just figure it out, or did somebody tell you about it? Anyways, they both work. Okay, so if you were able to follow what Jalen just showed us, you just got to watch out that you jump from x to y, right? If you do it my way, then you see all of the equations at the same time. Okay, so it's up to you what you want to do. Both work. Cool, cool. One more. Will I do the? Yeah, I will give you a bit of a crazier one. Ready? Um, 1/2 y minus 2 is equal to -5. This isn't crazy. I've seen crazier, Mr. Dirksen. This is nothing. Um, you decide what you want to do here, but I would bring this number over. You see that there's only y, right? There's no x. So you already know this is a special case. So I'm going to go -1/2 y is equal to -5 plus 2. I'm going to bring this -2 over, and then it's 1/2 y is equal to -3. And what must be done to get rid of this half? You need to multiply the whole thing by 2, right? If it's a third, then by 3. If it's 2, right, you go like this and like this. So this cancels out here, so you're left with y, and this is -6. And so let's sketch it. So this would be, I'm going to focus in on the negative, okay? That's why I modify my graph like that. I'm going to go 1, 2, 3, 4, 5, 6. And because I'm using a scale of 1, I don't need to add any numbers. That will change. So this is the line. It's a horizontal line right there. And that line is called y is equal to -6. Okay, horizontal line. Okay. So I'm going to give you a couple here to try. So I'm just going to give you these to copy and try them each individually. And that's going to be your warm-up for today. Okay, so here they are. I ask you to do these 3 steps for each of the following. Okay? So there's all the way from A to F. So I'm going to give you class time today to start this, and then tomorrow we'll dive in and do systems, or we do a bunch of them at the same time. Okay, so each one of them needs a graph separately. Okay. And if you're stuck all the way to C, and the graph I'll show you a little later.